Hello guys, so let's talk about construct a binary tree from Inorder and Postorder Traversal. So this question is pretty similar to 105, so if you didn't watch the video, please go back to watch so you probably know the basics idea on these two in order and pre-order stuff. But this question is based on in order and post order. So the basically, you need a helper function, so which is I do in order array and then in order index, which is starting and ending, and post order index and post order array. So this is actually how you actually do it. So what I would do is I know my root value is basically is the last one from the post order, right? So I can say in root val is equal to post order and the last index, right? So it's post n. And at this case, I know my value, then I should know my index in order. So for in I equal to in star, don't forget it's in star, and let's say equal to in n and I plus plus. So if my in order at I is equal to the root val, then index will become I and I break. So that is how you actually find the root value at in order array. So for this example, I do know my root value and I do know my root value again. So the size of the root left is actually pretty much the same, right? The root right is a little bit different. So let's just code it so you know what happens. So we need a helper variable which is left size. And what do you actually know is in index minus in star, right? This is still the same, and I can actually know my root new tree no, and then root dot val yes, and root dot left will become I call the helper function, and root dot right I call the helper function, and I return root. Okay, here's it. How do you actually know this? So in order should not have the problem, right? So the left it will become in star. So what do I actually know? Where should I start for root left? -1, right? And that would be exactly the same thing for right. So index +1 to in n. So in order is easy. How about post order? So let's work on the post order. Okay, the first thing is post order array. No problem, right? Post order array. Okay. So where should I actually start? Start from the root left. So if you look at the diagram over here, sorry, it's pretty rough. So the size is this. Left size is root left. So for the post order, sorry, for post order left size, it's actually the same, right? So it could be post order. Wait, what? Post star, sorry, post star, comma, post star plus left size. So if you want to plus the left size, which is including root val, right? Because we don't subtract 1 yet, and we do know, right, when we do the in order we need to subtract 1. So which is you need to subtract 1 on the post order stuff. Post order the left, and post order the right is pretty much the same. We don't need to subtract by 1. So post star post order plus left size. So that would be a right size, right? So why do I actually -1? This is because I will include extra variable, but on the post order value you need to -1 just in case you don't you don't overcount your index. So, and for root.right is pretty much the same. So you start from here and then here, right? But we already take the root.val away. So you would just do post n -1. There's a reason why we -1 because we already know post n is equal to root.val, and we don't want to do it again and just return root. And for the base case, I mean, I could definitely check for the install. If install greater than inN, and I will just return null. You can do the post star and post n, but doesn't matter. Same idea. And they just run it and see what happened. Okay, I do have error. So what happened? And root val, sorry, capital. Okay, they just copy and paste. All right, pretty good, and it should be okay. Yeah. All right, let's talk about time and space. So time and space is pretty much the same. All of n for both, because you construct the tree only once, and you won't traverse the array twice. So the time and space is all of n, and this question is pretty similar to 105, but I would recommend you to do 105 first before 106, because Postorder has a little bit index issue, which is -1 over here. But I do believe you can understand it. And that will be the video, and see you next time.